All right, time to solve some more difficult equations. And as you can see, the equations we're looking at right now are a lot more difficult than the ones we've seen to this date. All is going to be fine. It's just a direct extension of what we've already learned. Let's take a look at this first one. 3x minus 7 equals 20. Again, I want to emphasize we can use our intuition to solve these. We're using a lot of skills, formal math tools as well, but you can use your intuition. For instance, I'd say if 3x minus 7 equals 20, then I guess 3x should probably equal 27, and then x equals... Okay, but even so, I want to show you the skills we can use to do this a little more formally. What I see here is I see our unknown x, and a couple of things are happening to it. First, it's getting multiplied by 3, and we get a 3x, and then that has negative 7 being added to it. So then it'd say we're adding negative 7, and that's why we end up with our final expression on the left of 3x minus 7. And similar to before, when we want to use inverse operations to isolate x, exactly the same thing. So let's just take a look over here for a moment. Well, what are the inverse operations we'd have to take here in order to arrive back at x? Well, I think the first thing we'd have to do is add 7. Right? That's going to be the inverse of this last operation. And then we're going to want to multiply, I'm going to use a multiplication dot here, multiply by 1/3, right, to get back to x. So let's do that. Let's see what happens. All right, so on the left here, I'm going to add 7 to this left-hand side of the equation. Of course, I'm going to do the exact same thing to the right-hand side of the equation. We are left with a new equation of 3 times x equals 27, just as we kind of said before with our intuition. All right, now we know the next step to isolate x is multiplying by 1/3. Let's go ahead and multiply by 1/3. I'll do a different color here. So I'm going to multiply by 1/3. I'm going to multiply by 1/3 on both sides. 1/3 times 3, that's going to give us 1x. Fantastic. So we have 1x equaling 27 times 1/3 is 9. So I believe that the solution to this equation is 9. Fantastic. Let's go ahead and check. Always a good idea to check. And to check your solution, you write down the original equation. So in this case, 3x minus 7 equals 20. Then you substitute in your candidate for the solution. 3 times 9 minus 7. Put a little question mark on top of your equal sign. You're saying, hey, does that equal 20? I don't know. 27 minus 7, does that equal 20? Yes, indeed. 20 equals 20. Boom. Check. You're letting your reader know, hey, I absolutely know that we have found the solution to that equation, and it's 9. So all you saw was that instead of having to undo one operation on x, we just had to undo 2 operations on x. That's it. That's the whole thing. All right, this next example is a little trickier. It looks like, well, we got to be really careful here because we always read from left to right, but actually the first thing that's happening to our unknown x is it's actually being multiplied by negative 3/5. That's actually the first thing that happens to it. I might have to make a little room here. Give me one moment. Awesome, here we go. So we saw the first thing that happened to x is it got multiplied by negative 3/5. I'm going to use the multiplication dot here actually. Multiplied by negative 3/5. If I could write 3/5, that would be great. Amazing. And then the next thing that happened to it was it had negative 4 added to it. And that's how we ended up with the right expression of this equation over here. All right, so what we need to do is we need to undo that so we can get x by itself. So the first thing we need to do is add 4 to undo this step. And then we're going to need to multiply by negative 5/3 in order to undo this step. And you really want to make sure that you're doing these in the correct order, right? If you had multiplied by negative 5/3 first and then added 4, if you did these in the backwards order, you would not come up with the correct solution. Hopefully you'd find that mistake when you try checking. Okay, so first things first, let's add 4 to both sides of our equation. So adding 4 here. 12 plus 4 is 16. I know that negative 4 and plus 4, those are additive inverses. We get 0. So get negative 3/5 times x. Fantastic. And as we thought, the next thing we're going to do is multiply by negative 5/3. I'm going to do that in a different color here. So I'm going to multiply by negative 5/3. Multiply the left-hand side by the exact same thing. We end up with, well, on the right, negative 3/5 times negative 5/3 gives us 1. So we're going to have a positive 1x. That's fantastic. On the left-hand side, woof, we're going to get a nasty number. Let's see, something like negative 80 over 3. All right. Like we said before, we're not always going to get such nice answers. Holy cow. So our candidate for a solution is negative 80 over 3. Blah. You know what we got to do? We got to check. All right. So we know how to check. We write down the original equation again. All right. So our original equation was 12 equals negative 4 minus 3/5 times x. All right, that's our original. Let's go ahead and substitute in our candidate solution. 3/5 times negative 80 over 3. Oh my lord. Okay, couple of things. Let's do some simplifying right off the bat. I know that, let's see, this 3 and 3, they'll cancel out to give 1. 5 and 80, those will cancel out to give 16 and 1 there. I know I'm going to be subtracting a negative, so I'm going to rewrite this as, oops, excuse me, I forgot to put my little question mark there. 12, does that equal negative 4 plus 16? Oh, wow. Check it out. It works. Fantastic. Okay, so you can see how these tools allow us to solve some more complicated equations with some more complicated solutions. All right, I want to show you one more thing quickly. All right, check it out. In this case, we see on the left-hand side of this first equation that we've got, it's not simplified, right? We've got some distribution we can do. And so one strategy when you're left with something like this is to go ahead and actually simplify the left-hand side first. So here we've got 3x minus 12 equals 24. All right, and I think this is not going to be so bad, right? The two things that happened to x is we got multiplied by 3, then we had adding negative 12. We're going to undo that by adding positive 12, and then multiplying by 1/3. I'm going to go through this a little quickly, but hopefully we can follow along. So I'll go ahead and I'll add 12 to both sides of this equation. We end up with, excuse me, I should have done that in this order. We end up with, let's see, 3x equals 36. Maybe you can just use your intuition right there and say that x equals 12. You could also have gone ahead and multiplied by 1/3 on both sides. All right, life is good. I do want to give you the heads up that if you wanted to, you could actually do this in another way. If you look at our variable x in this case, you could also say that actually, without doing the distribution and simplifying first, right, when we simplified this to here, the two things that happened to x were multiplying by 3 and then adding negative 12. If you don't simplify the left-hand side, which I usually do, but just wanted to show you this, you could say the first thing happening to x is subtracting 4, or adding negative 4, and then multiplying by 3. What? And then multiplying by 3. Meaning, to undo that, the steps would be multiply by 1/3 and then add 4. Check this out, right? We actually never distribute in this case. The first thing we could do is multiply by 1/3 on both sides. We're going to multiply everything by 1/3. Now note to self, got to be careful here. A lot of folks think, wait, maybe I need to distribute this 1/3. Look, this is 1/3 times 3 times x minus 4. 1/3 times 3 is 1. Boom, we get 1 times x minus 4, also known as just x minus 4. 1/3 of 24 is 8. X equals 12. We get the exact same solution using these two different strategies. I just wanted to put that on your radar. Okay, one more example. What happens when there are variables on both sides of the equation? Whoa, check out this tough equation. Oh my God, there's so many things going on. All right, here we go. These are the steps we're going to use to solve these types of equations. First things first, just simplify both sides of the equation. So we'll say simplify both sides of the equation. We have a lot of distribution going on right now. There are probably going to be some like terms you could collect. Let's do that. Now, I bet you could do that on your own. I'm going to kind of walk you through it anyway. All right, so let's see. I'm going to distribute this 5. I'm going to get negative 25b plus 25 minus 6 equals, let's see, negative 20 minus 30b minus 8b. I'm going to collect some like terms. I think I've got negative 25b plus 19 equals negative 20 minus 38b. All right, so the first thing we did was we went ahead and we just simplified the left-hand side and the right-hand side. We still have this issue where we have some b's on the left and some b's on the right. Well, check it out. We're going to kind of use the similar idea of inverse operations. What I'm going to do is I would love it if we just had these b's on one side of the equation, but not both. So what am I going to do? I'm going to take a look at this negative 38b, and you know what I'm going to do to the right-hand side of the equation? I'm going to add 38b. Right? I know that negative 38b plus positive 38b, these are going to add to 0. They're going to go ahead and they're going to cancel out. That's going to be amazing, right? And then I won't have any b's on that side. Of course, I got to do the exact same thing to the left-hand side of the equation. So I'm going to go ahead and I'm going to add 38b here. All right. And when we do that, let's see, 38b plus negative 25b, I think I get 13b. I should probably do this in the correct font here. No, we'll do it in black ink. So you get, let's see, 13b plus 19 equals negative 20. And all right, now we're ready to proceed as before. So step 2 of this process was, let's say, collect all variables on one side of equation. Collect all unknowns, if you will, on one side of the equation. On one side. And then from here, it's proceed as normal, just like we've been doing earlier in this lesson. Right? I see that this b has had 2 things done to it. It's been multiplied by 13, then added 19. So let's undo those. Let's first add negative 19, or subtract 19, however you want to say that. So I'm going to add negative 19. We end up with 13 times b equals negative 39. I'm going to go ahead and multiply both sides by 1/13. All right, 1/13. And we end up with, let's see, b equals negative 3. All right, now I got to say, this is a long and complicated equation. When you have these long and complicated equations, right, it's easy to just go through the motions and say, I'm done. All right. But who knows, man? Maybe we made a mistake in there somewhere. So what we really want to do is check. So we're going to check. All right, here we go. We're going to write down the original equation here, which was 5 times the quantity of, I'm going to make a smaller font here. Let's say 5 times the quantity of negative 5b plus 5 minus 6 equals 5 times the quantity of, negative 5 times the quantity of 4 plus 6b minus 8b. Holy cow. All right, let's substitute in our potential solution of negative 3. So we have 5 times negative 5 times negative 3 plus 5 minus 6 equals negative 5 times the quantity of 4 plus 6 times negative 3 minus 8 times negative 3. Holy cow. This is tough, but this is what it takes. This is what it takes. I know it's kind of small ink, but bear with me here. So let's see. That's going to be 15 plus 5 is 20, so 5 times 20 minus 6. Does that equal to, excuse me, I should have been putting these question marks here. Is that equal to negative 5 times, let's see, negative 18 plus 4 is negative 14. 14. And then this would be plus 24. So you have 100 minus 6. Is that equal to 70 plus 24? Let's see, 94. Does that equal? Oh my God, 94. Amazing. So we have checked our solution. And it really pays to check our solutions, especially to these longer, more complicated equations.